Hello, my name is Colin. My partner is Joe Greene, and this is the Plastics Lab Sustainable Recycling Program Development Project. The project sponsor is Penn State Behrend. The goal of this project is to implement a sustainable and comprehensive recycling program in the Plastics Lab that will result in a measurable reduction of material, all plastic, metal, and paper, from entering the waste stream by at least 70%. For our hypothesis to be proven true, three things must occur. We must reduce the amount of mass exiting the plastics lab by at least 70%. The project must be fully self-funded, and we must ensure the longevity of the program after the senior project team graduates. We have evaluated both chemical and mechanical recycling methods for use in the lab. We have determined that mechanical recycling is best for our use case due to its ease of use and cost effectiveness. As mentioned previously, the sustainability of the operation itself is key to our project. To do this in the near future, we will rely on the Plastics Club to sort and process the material, whereas after, we are going to develop a sustainability tech elective where students will operate this program and learn about various methods of recycling. To aid in future operation, we have developed a recycling program manual that consists of machine maps, ASTM standards for polymer testing for quality control, standard operating procedures to operate equipment for the program, and material testing request forms. The recycling process used in the lab starts with pellets for plastics processing equipment, then part production, and we collect and sort this material, we granulate it, and then we run it through an extrusion line, and then chop up the single strand of material back into pellets for future use.
Audit results. In the spring and fall semester of 2023, two-week audits were performed in the plastics lab. Both of these audits yielded a result of 72.5% waste reduction, which guided us to our hypothesis of 70%, with a 2.5% buffer. In the spring semester of 2024, an 11-week audit was performed. This audit yielded a value of 70.3% waste reduction, achieving our hypothesis goal by 0.3%. Melt flow rate results. Melt flow rate data was taken to determine the melt flow rate differences between granulated and pelletized material. A value of no more than 10% difference was required. For recycled polyethylene, we saw a value of 2.3% difference. This falls well below our 10% value. For high-density polyethylene, we saw a 6.46% difference, also falling below that 10% limit. We would like to thank our project sponsor, Penn State Behrend and Mr. Brad Johnson, our advisors, Dr. Gamini Mendis and Mr. Brian Young, our graders, Dr. Xiaoxi Zhang, Dr. Sammy Madbully, and Mr. Brad Johnson.